This is a University of Lethbridge Department of Mathematics and Computer Science 2610 video by Nicole Wilson. In this video we are going to do lab exercise 0, the sample lab question 1d, in which we are asked to build the physical circuit for this question. So as you may recall, question 1 of lab exercise 0, we've already done 3 parts of. We've created the truth table, the logic circuit, and our wiring diagram. We're going to be referencing the wiring diagram while we actually wire. So I strongly urge you in the more complicated ones or ones giving you trouble to print a bigger version of it if you don't already have one, and then use something like a highlighter to mark when you've connected each wire. You stand a much better chance of getting it right if you keep track of what you're doing. This isn't that complicated one, there's not that many wires, so I have to admit I probably wouldn't usually do it here, but you will get some very complicated ones as we go. So referencing our wiring diagram, we can see that we need 4 chips. We need a hex inverter, which is a 4. So I'm going to put in a number 4 chip. We need a quad 2-input NAND gate, which is a 0, 0. Again, I'm making sure I've got these oriented properly. I've got that half circle on this side, and I pop it down. I don't put them right next to each other because it's pretty hard to get a chip puller in between if they're right flush with each other, and we don't want to pull it up on one side or the other first because that will break the pins. We need a 0,8 quad 2-input AND gate. Do check the chips as you go to make sure that none of the legs are folded or broken. If they are, your chip won't work very well. And then number 32, a quad 2-input OR gate. Again, the wiring diagram is made with reference to our manual, so we know exactly how to hook all these things up. Now I need to power and ground all of my chips. Hopefully I'll get them right. Doesn't fit. Power. Ground. So I'm going to pause and do the rest of these. I'm not going to pause and do the rest of these. I don't know how to pause. I never did say I was a good cinematographer. Or whatever this is. However, if you don't want to watch me do this, you should feel free to skip ahead. On the other hand, maybe I'll say something exciting that will get you extra marks while I'm doing this. Probably not. So that's powered and grounded. And we need to power and ground the next one. And then power and ground the last one. Are you glad there's only 4 chips in this one? I am. And I'm just going to make sure I've got those lined up properly. Okay, before we use these chips, we need to test them. This is the boring part that people like to skip. Trust me, if you shouldn't have skipped it, you'll know. It might take you all day to find out, but you'll find out. Slightly larger wire than that. Here we go. Okay, so 04 is my inverter. There's 6 gates on the hex inverter. Let me turn this on. And I just very quickly go through and make sure all of them are inverting. Good. Now I'm going to check the 0, 0, which requires each gate in there is a 2-input NAND gate, and there's 4 of them. So I've got 2 coming in, 1 going out. NAND, the only time a NAND is going to give us an on or a 1 is if both inputs are 0. Sure enough, 2 zeros, 2 opens are giving us a light on. So 0, 1. I do gray code for this because it's faster, but this is not how you write it up. Remember to use standard order. So 0, 1, 1, 1, 1, 0. That's bad. Why is the light on with a 1, 0? Oh, NAND, wait a minute. No, NAND is 3 1s, 1 0. The only time we get a 0 is with 1 1. So there we go. On, off, on. Okay, next one. So both off is on. 0 0, 0 1, 1 1 turns it off, 1 0 turns it on. Zero 0 is on, 0 1 is on, 1 1 is off, 1 0 is on. And then our last one. 0 0 is on, 0 1 is on, 1 1 is off, 1 0 is on. Okay, next is the 0 8, which is the quad input AND gate. The only time the AND gate is on is if we have 2 1s. So 0 0 is off, 0 1 should be off, 1 1 should be on, and 1 0 should be off. It is. So there's our 0 0 is off, 0 1 is off, 1 1 is on, 1 0 is off. 2 on the other side. Zero 0 is off, 0 1 is off, 1 1 is on, and 1 0 is off. Last one. 0 0, 0 1, 1 1, 1 0. I don't know if I already mentioned it, but the order I'm testing these in is called gray code because it's only one switch to get to the next state all the time. There's more than one gray code, but okay, now we're doing the quad 2 input OR gate. So 0 0 gives us an off, everything else should give us an on. So there's 0 0, 0 1, 1 1, 1 0. Uh, 0 0, 0 1, 1 1, 1 0. 0 0, 0 1, 1 1, 1 0. And the last one, 0 0, 0 1, 1 1, 1 0. There. So all our chips are working properly. I can turn that off because we don't need it right now. Okay, so now we're going to connect our wires and test to make sure our chip actually works, or our circuit actually works. So we need to connect our switches to the breadboard. I like to pick a row for my X, or my first variable, and a different one for my second one. So this is all 4 of these are connected to X and all 4 of these to Y. Then I need to do a not X. So I'm going to use the first inverter for X. And so as you can see, I've just highlighted the section I connected. And then one for Y. any one of these 4 along here that were open could be used. So that's in, out, in. Okay, now I need to hook my not X to, oh, not for a long time. So I'm going to look at the AND gate in the next one. I need to hook up an X and a Y to that. So I'm doing X NAND Y. So there's my X, and I hook up to the first NAND gate, and the Y, I'm also hooking up to this first NAND gate in the second lead. And then that NAND gate is getting connected further down. In the next chip, I have one AND gate I'm using, and it's hooking up not X and not Y. So the output from this one goes into one of these AND gates. I'm going to use the first one. And the output from this inverter hooks up to the second input. Now on the last chip, I am ORing together the output from the NAND gate and the AND gate I've used. So this is the NAND gate output, and it's going into the first OR gate here. And this is the AND gate output, and it's going into the second input on the 32 or the OR. And then that hooks up to a light. So now we dig out the truth table, and we're going to test to make sure we actually get what we thought we would. So in our truth table, it says that if X and Y are both 0, we should be outputting 1. We are. If X and Y are 0 and 1 respectively, we should have a 1. If our inputs are 1, 0, it should output a 1. And if our inputs are 1, 1, it should output a 0, and it does. Now, this is an extremely silly circuit we've just built. The reason it's so silly is the output for this entire big ugly here is the exact same as it is for just NAND. Or in other words, we built a very, very complicated NAND gate. However, the methods that we use to do this are standard whether our outcome is silly or not. So now in our report, we write built and tested, see completion form submitted in person. If you had to design some kind of a test for this, or in other words, testing all of the inputs was not feasible, then we would give specifically which ones we tested and explain why we chose those ones. So now packing up the kit, all of the wires get put back together and bundled. We pull everything out of our breadboard. Every wire must come out when you pack up at the end of lab. It's tempting to leave the power and grounding wires in, but not all the chips are the same size, so it doesn't actually always save you any work. Plus, somebody else is also using the kit you're using, so you want to make sure that it's in a ready state for them. Remember to get your chips out. We always use our chip puller. You can hear it when they are coming out. Do examine the chips both before and after you use them to make sure that we don't have any bent pins that will prevent them from working properly. And that is how you build a chip for 1D, or build a circuit for 1D.